got the low-hanging fruit. Because the high-class fruit is not very funky, but the low-class fruit is sweet, sharp, get munchy when you smoke that fruit. It smells like a skunky. Come on.
So since the last video, gotten a few comments back concerning the spirit level experiment to determine that the Earth is flat. Now, one of the retorts that I've gotten was to simply look out of the window in order to see the curvature.
Ah, yes, the YouTube comments section.
You will never find a more wretched hive of scum and villainy.
So today I'd like to take this time to invite you to take a flight with me. A lot of people subscribe to the idea that you can simply get onto a plane and look out of the window in order to see the curvature of the Earth.
You are technically correct. The best kind of correct.
However, I'd imagine that some of these individuals who say such things haven't really taken a whole lot of flights and probably haven't spent a whole lot of time looking out windows.
Fuck the whore!
So, while we have this time together, let's enjoy the beautiful scenery here and the complete lack of curvature with a quick vocabulary lesson.
The Earth's curvature technically exists between any 2 points on Earth. Your lawn curves from one end to the other, although said curvature is very, very minor. As you raise in altitude above the Earth, the curvature becomes more and more obvious. If you go sit on the moon and look at Earth, the curvature is pretty fucking apparent. What D. Marble appears to be attempting to do is measure the Earth's curvature out of the window of a little 2-engine pond skipper using MS Paint. He claims the expected result is curvature. How much curvature should he expect? Oh, that's not important. How is he going to measure curvature? MS Paint, obviously. Again, D. Marble fails to ask the question in a proper scientific manner. The most important part of an experiment is the hypothesis. If you do not have a good question, how can you hope to find a worthwhile answer? If D. Marble would have calculated the expected curvature from his window at cruising altitude and then accurately measured it, perhaps there'd be something worthwhile here. I feel as though I have nothing to debunk here because there's nothing being said. I guess old D. Marble knows how to draw a line in MS Paint. Congratulations.
That'll do, pig.
According to the heliocentric model, the spinning ball Earth, we're told that at the equator, the Earth is spinning at 1,032 miles per hour eastward. Now, because the United States is a little higher in latitude from the equator, let's say that the speed slows down to about 850 miles per hour. Now, I was on a plane heading from the East Coast to the West Coast at 515 miles per hour.
Fuck yeah!
Now, given those numbers, I conclude that
Wait for it.
an East Coast to West Coast flight
Wait for it.
should be a physical impossibility. Now, why do I say that? Well, for example, and I'll just use this to make things simple.
You serious?
The plane is only going 515 miles per hour. The ground beneath the plane is moving at 850 miles per hour. Therefore, the ground is always outpacing the plane over 300 miles per hour. So, being able to fly from the East Coast to the West Coast, that should never happen.
The reason we can move along the face of the Earth is we are all going at the same speed as the rotation of the Earth. If, for example, you fly a drone inside a train, the drone doesn't instantly crash against the back of the train. Its rest motion is the same speed and direction as the train. This exact same principle applies to an aircraft.
Almost as if we live on a flat, stationary Earth. Because that's what it is. I traveled 203 miles recording level flight. During that 203 miles, according to curvature math, or spherical trigonometry,
Don't wave your fancy degrees at me.
the plane should have had to compensate for 5 miles of curvature going downward. Now, what I showed you was level flight for 203 miles. Bubble stayed centered the whole time. Generally the whole time. Now, had the plane been dipping the nose forward, the bubble would have ended up towards the back of the spirit level, like so. But that's not what happened. Because the plane was independent of the Earth's surface during that flight, that means in order to maintain altitude of 34,000 feet, so in order to maintain that, while flying level, the only way that the plane would have maintained that altitude while the Earth's surface was curving beneath it would be to decrease velocity and thus cause the airplane to slowly sink.
Game over, man. It's game over.
At the end of that 203 miles, the plane still would have had to compensate for curvature because, you see, the plane was still independent of the surface of the Earth. So the plane was flying level, but the ground beneath, according to the heliocentric model, the ground was still curving beneath the airplane. So the plane's flying level and the ground's still curving beneath. So at some point, in order to get proper orientation back to the ground, the plane would have had to take a dive or dip the nose, as I say.
Perhaps you should listen to your own video, D-Marble. You kinda already spoiled my debunking.
Now, before we get into this next part, let's listen to a pilot's testimony.
I was an airline pilot for Delta for 26 years. A pilot's primary flight instrument is his artificial horizon, which he has to be maintained level to keep from climbing and descending.
Did you catch that? A plane flies horizontal with respect to the Earth's horizon. A plane's altitude is taken with respect to the Earth. You may not realize this, but piloting involves many tiny adjustments over the course of the flight. The roll, yaw, and most important here, pitch, are all in constant adjustment to provide you the most level flight possible. As a plane flies around the Earth, its primary concern is keeping altitude. Since that altitude is determined by the height above the Earth, a plane would follow the curvature of the Earth in order to maintain its altitude. Any and all adjustments are in response to altitude, not curvature, although curvature is responsible for the change in altitude. If I were to sit on the moon and watch your flight, D-Marble, you would appear to change orientation, because I have a different frame of reference. You would not feel this change because your frame of reference is the Earth below you.